A Nobel Prize-winning physicist has just issued a chilling warning. What the James Webb Telescope is seeing out there doesn't match our theories. Galaxies too old, structures too complex. Have we misunderstood the entire universe? Just days after we explored Julong, the largest Milky Way-like galaxy ever found forming shockingly early in the universe, scientists have now stumbled upon something even more mind-blowing, and it's sending shock waves through the astronomy community. In a discovery that's not just surprising but genuinely unsettling, the Webb telescope has helped uncover a colossal barred spiral galaxy known as J0107a, existing a staggering 11.1 billion years ago when the universe was just a fraction of its current age. Teaming up with the ALMA Observatory, researchers revealed that J0107a is not only structured like our Milky Way with a central bar and spiral arms, but it's also over 10 times more massive and is creating stars at a jaw-dropping pace, about 300 times faster than our galaxy today. What's truly baffling? Galaxies from this era were expected to be messy, chaotic, and unformed, yet J0107a is remarkably well organized. Even more shocking, there's no sign of galactic mergers or collisions that could explain such rapid growth. Its calm, isolated formation during such a chaotic period completely challenges what we thought we knew about galaxy evolution. But that's not all. The Webb telescope has just delivered another game-changing discovery that's igniting fierce debate across the scientific world. In its deepest, longest observation ever, a session that spanned more than 120 continuous hours, Webb focused on a single target and captured a breathtaking image that may forever reshape our understanding of the cosmos. The image reveals spiraling arcs of light, distant galaxies that formed during the cosmic dawn, a time when the universe was only a few million years old. But here's the shocking part. The farther Webb peers into the ancient universe, the more unexpected and puzzling mysteries it uncovers. Scientists initially believed Webb would simply confirm long-held ideas about the early universe, that galaxies slowly took shape after the Big Bang, starting small and gradually building up. But now what Webb is actually seeing paints a completely different picture. Some astronomers are beginning to wonder if we're witnessing what feels like an entirely different universe, one brimming with massive, fully formed galaxies and strange cosmic structures that shouldn't even exist this early. So what exactly did the Webb telescope uncover that has scientists questioning everything? And why are some now wondering if Webb is revealing what feels like an entirely different universe? Let's rewind to 2016, when NASA's Hubble Space Telescope made headlines by discovering GNZ11, the most distant and oldest known galaxy at that time. The light from GNZ11 had traveled 13.4 billion years to reach us, meaning we were seeing the galaxy as it existed just 400 million years after the Big Bang, when the universe was barely 3% of its current age. But the real shock wasn't just its distance. It was GNZ11's unexpected size, brightness, and star formation activity. By all existing models, a galaxy that big, that organized, and that active simply shouldn't have existed so soon after the birth of the universe. It didn't fit the timeline we thought we understood. Even then, many astronomers dismissed it as a cosmic outlier, perhaps a 1 in a billion chance, an exception rather than the rule. After all, most galaxies Hubble observed at similar distances seemed to match our theoretical expectations perfectly. There was no urgent reason to rewrite the playbook. But what Webb is seeing now suggests GNZ11 may not have been an exception after all. It's starting to look like the early universe might have been full of massive, mature galaxies far earlier than we ever imagined. Webb isn't just finding one anomaly, it's finding many, enough to suggest we might have been missing a huge piece of the cosmic puzzle all along. But everything changed in 2022 when the Webb telescope officially began its science operations. Built to peer deeper into space and further back in time than any telescope before it, Webb immediately began delivering discoveries that no one saw coming. In its very first deep-field image, Webb shattered previous records, detecting multiple galaxies that were far older and farther away than anything the Hubble Space Telescope had ever captured. One of the most shocking finds was JWST, a galaxy that existed just 350 million years after the Big Bang. even earlier than the previously record-breaking GNZ11. This wasn't a rare cosmic fluke anymore. Suddenly, multiple ancient, massive, and surprisingly mature galaxies were being found scattered throughout the early universe. This set off alarm bells in the astronomy world. If these early, fully formed galaxies were popping up regularly, it meant something might be fundamentally wrong with our current models of galaxy formation and cosmic evolution. And as Webb continued its mission, the mystery deepened. Astronomers began uncovering even stranger objects, so luminous, so massive, and appearing so soon after the Big Bang, that scientists are now unsure what they're even looking at. Are these enormous galaxies, supermassive black holes, or something entirely unknown? What's most troubling is that these discoveries don't fit anywhere in the timeline or framework of our standard cosmological theories. Some of these objects seem to have existed just 300 million years after the Big Bang, or possibly even earlier. And the problem is simple but huge. Our current models of the universe don't predict this. They can't explain this. According to our current cosmological models, there simply shouldn't have been enough time for so many massive, bright structures to form so early in the universe's history. Until recently, the most distant known galaxy was Glass, Z13, believed to have existed just 290 million years after the Big Bang. Even that galaxy left scientists scratching their heads because its sheer size seemed impossible for such an early cosmic era. But just when researchers thought they had reached the edge of what's possible, the Webb telescope made yet another astonishing discovery. Webb has now spotted something even more perplexing, an object named MOM, Z14 dating back to just 280 million years after the Big Bang. This object, which shows a redshift of 14.44, surpasses the previous record holder JWST, Z13, with its redshift of 14.32. And this latest find, it completely breaks the current understanding of the early universe. Scientists aren't even sure what MOM, Z14 actually is. Is it a galaxy, a black hole, something entirely new? Whatever it is, it simply shouldn't exist this soon after the Big Bang if our models are correct. But it doesn't stop there. Astronomers are now uncovering a surprising number of galaxies at redshifts between 15 and 30, which push even deeper into cosmic history. Some of these galaxies are still being verified with more precise spectroscopic testing, but there are already several strong candidates for galaxies with redshifts greater than 15. In groundbreaking new research, scientists now suggest that if even a fraction of these early galaxy candidates are confirmed at redshifts greater than 15, it would seriously challenge the foundation of modern cosmology. With each new Webb discovery, astronomers are finding galaxies that aren't just unexpectedly massive, they're also well-structured and mature, appearing shockingly soon after the Big Bang. The sudden appearance of these bright, organized galaxies in the universe's infancy is raising enormous questions. Many researchers now believe that while our standard cosmological models hold up well until about a redshift of 10, the moment we peer beyond that into the earliest chapters of the cosmos, everything starts to break away from what our theories predicted. So far, no existing model can fully account for what we're observing in those first few million years after the Big Bang. But the mystery doesn't end there. It's not just the galaxies that are puzzling scientists. New data also suggests that the expansion rate of the universe isn't as steady as we once thought. This implies that dark energy, the mysterious force believed to drive cosmic expansion, might actually be evolving and losing strength over time. If that's true, it would overturn a major assumption of modern cosmology. It would also challenge Einstein's long-held idea that the cosmological constant remains unchanged. These stunning revelations suggest we may be on the edge of a scientific revolution, one that could completely reshape our understanding of the universe's origin, evolution, and ultimate fate. These recent discoveries are pointing to something truly profound. We might be missing a crucial piece of the cosmic puzzle. Or maybe something extraordinarily strange happened in the universe's earliest moments that we still don't fully understand. Our current theories just can't explain it. With the most powerful telescopes we have today, we're peering back only a few hundred million years after the Big Bang, and what we see is baffling. One of the very first galaxies formed already harbors a supermassive black hole at its center. This presents a huge challenge. How did such massive black holes form so quickly when there was barely any time after the Big Bang? Until now, by studying the nearby universe and tracing all the way back to the cosmic microwave background radiation dating to about a redshift of 1100, scientists believe the universe began as a hot, infinitely dense point. The unexpected discovery of massive, well-structured galaxies so soon after the Big Bang simply doesn't align with standard cosmological models. Because of this, some scientists are exploring bold alternatives that go beyond the traditional Big Bang theory. One fascinating idea is that other universes might have existed before ours and could have interacted with our universe in its infancy. Speculative theories like string theory and brane cosmology even suggest the existence of parallel universes filled with dark matter, possibly connected to ours through hidden extra dimensions. Another mind-bending idea gaining traction is the concept of a mirror universe, a cosmos that runs backward in time, perfectly symmetric to our own. But among these wild theories, one in particular is capturing the spotlight: conformal cyclic cosmology. Conformal cyclic cosmology suggests that our universe isn't a one-off event, but part of an infinite chain of universes, each born from the ashes of the last in an endless cycle of cosmic rebirth. According to Penrose, subtle imprints from the universe before ours might still be detectable as faint patterns in the cosmic microwave background radiation, the afterglow of the Big Bang. What's truly fascinating is that the early massive galaxies recently spotted by the Webb telescope might actually fit perfectly within conformal cyclic cosmology predictions. This hints that our universe could be far older, far more complex, and more mysterious than we ever dared to imagine. Turns out we got the universe all wrong. Classic us. Hit that subscribe button, share your thoughts below, and let's keep exploring the together. What do you think? Could Trappist we be home to life? Or are we chasing a cosmic merge? Thanks for watching, and we'll see you in the next.